Hi students, I am Prashansini Sandamini. I am an undergraduate from Faculty of Medicine, University of Moratuvar. Today I am going to discuss with you all the Unit 4 of Grade 10, which is Newton's Law of Motion. As the name suggests, it's already related with Newton's laws. There are 3 Newton laws, so before we are moving to the discussion about the Newton's law, first we have to clarify the nature of the forces and how it affects. So thereafter we can discuss each of the Newton laws 1, 2 and 3 separately, and at the end we have to discuss about the momentum and the terms mass and the weight. That is the big picture of our lesson. So, but this is a very small lesson. So, first we have to understand what is force. Force එකක් කියන්නේ මොකක්ද කියලා තමයි එකටම අපි understand කරගන්න ඕන. Force is applied when we push, pull, lift or compress. That means if you keep an object, you can push it. This is called pushing. And අපි කියන්නේ තල්ලු කරනවා කියලා. And if you pull it, think if you are tie a rope to here and you pull, then this is pulling. අපි නැත්තම් ඒකට කියනවා අදිනවා කියලා දෙයක්. And another thing is lifting. You are keeping this box on the table or somewhere else and you are lifting. That's mean an upward movement, right? Lift කරනවා. උස්සනවා දෙයක්. And compress. You can keep thing like what we are usually compress. Thing like something which you can compress easily. A chewing gum or something. Then you are giving a downward force. What happened? It compress against this table or any surface. So that is basically a force. So these are the way of applying a force. You can be a push, a pull, a lift or a compress. So to move a body at rest, that means what? A rest mean මොකක් හරි object එකක් rest එකේ ඉන්නවා කියන්නේ there is no motion and also it is placing in the same place. Time එක කොච්චර ගියත් අපි හැම වෙලේම ඔබ්සර්ව් කරද්දී ඒ ඔබ්ජෙක්ට් එක තියෙන එකම ප්ලේස් එකේ නම් ලොකේෂන් එක සේම් නම් ඒ වෙලාවට අපි කියන්නේ රෙස්ට් කියලා. රෙස්ට් එකේ ඉන්නවා කියන්නේ කිසිම මූවමන්ට් එකක් නැහැ කියන එක. එතකොට a force must be applied in the direction of the motion. අපිට ඔබ්ජෙක්ට් එක move කරන්න ඕන. Let's think you want to move this box, right? This is the object that you are concerning here, or the body you are concerning here. So if you want to move this box to this direction, the force also applied to this direction. Example, if you want to move this to this direction, you want to push, right? Then you applying push to here. That is push. But if you are pulling it, it's also done to the same direction. That is the thing. So even it's push or pull or whatever the type of force you are using, you have to give it to the direction that you want to move. මට move කරන්න ඕන මේ direction එකට. එහෙනම් මම force එක දෙන්නත් ඕන ඒ direction එකටම තමයි. ඒක තමයි මේ statement එකෙන් කියන්නේ. හරිද? An object starts moving only when the applied force is sufficient to overcome any resistive force acting on it. ඒකත් important. අපි දන්නවා සාමාන්‍යයෙන් අපි හිතමු මම මේ ටික අයින් කරන්න. දැන් හිතන්න ගෙදර ලොකු very big cupboard එකක් තියෙනවා. Let's think there is a very huge cupboard placed on the floor. So you want to move this cupboard to this direction, but this is very huge, right? So you try your best by applying a force like this. What happened? At the initially it doesn't move වෙනවද? නෑ. there is a resistive force. Resistive කියලා කියන්නේ resistance or the resistance. resistive හරි resistance හරි ඒ word එකේ meaning එක තමයි ප්‍රතිරෝධයක් තියෙනවා. අපි කියන සිංහලෙන් කියන්නේ එහෙමයි. ප්‍රතිරෝධයක් or maybe a opposite direction force එකක් තියෙනවා. example දැන් හිතන්න ඔයා move කරන්නේ මේ අතර නම් flow එකෙන් මේ object එකට දෙනවා. there is a resistive force given by this object toward the opposite direction that you are trying to move. ඒ object එක move වෙලා නැති වෙන්න පුළුවන්. හැබැයි you are trying to move කරන්න යන්නේ මේ direction එකට නම් object එක බලන්නේ ඒකට opposite direction resistive force එකක් දීලා ඉන්න තැනම ඉන්න. හරිද? අපි ඕකට පස්සේ මේකේ when we are moving further ahead of these lessons we will find a word friction. So this is this force. ඒ opposite force එකේ නම තමයි frictional force. එතකොට මේ if that object want to overcome this barrier and if that object want to move ඒ friction force එක නැත්නම් ඒ resistive force එකට වඩා වැඩි greater force එකක් have to apply. This person have to apply a greater force than this resistive force. Then eventually the object start moving. That is the basic, very basic understanding about the force. Okay. Then the effects of the resistive forces. Think if you try to push a table and it doesn't move. So what you can do is you can increase the force until the motion starts. That's what I discussed earlier too. And think there is a bus, right? It is breakdown the road. So now you guys discuss what we have to do. You have to carry this bus to a nearby place where it is can be repaired again. So can this done by one person? Think you are the one who want to do this, right? So you are giving a push. Does this bus move? I'm like yeah. It cannot be okay, right? Even though you thought you don't have superhero powers. So what you can do is you can join many other people. Then what happen? Each and everyone is giving their own forces to this bus, right? What happen now is think a single person can give 50 Newton force, and I will explain these Newton words and everything later on. Think the force has a unit which is Newton. So think one person giving 50 Newton, then another one is also giving 50. This person is so strengthful, so this one is giving 100 likewise. Totally now 200. Think it is enough to move. Then the bus is start moving. That's the logic behind this. That means it can overcome the resistance given by this bus against your forces. Okay. Then the bus can move. Then bus start moving to this direction. So it is mentioned about the friction term too, but there is a separate lesson to learn about this friction. A resistive force opposing the motion of an object is the friction. අපි ඒක දැනගන්න ඕන. හරිද? For every object if we trying to move, there is a resistive force it start to generate. ඒ surface එකේ resistive force එකක් දෙනවා ඒ object එක move වෙන එකට. So that is simply the friction. If the applied force is less than friction, what happen? Friction කියන එක මේ resistant force එක වැඩි වෙනවා. Think this is the box, this is you. Okay. Then හිතමු this is the friction force and this is the force you are giving. You want to move this to this direction. That's why you are pushing it harder and harder. what happened from the floor to this box? It is giving this kind of resistive force which is called friction. That's why we cannot move any kind of object easily as we thought. So this is the applied force and this is the friction. So if the applied force is smaller, what happens? If this is smaller, you cannot move this to this direction. Friction is larger. So can you see any movement? No. Think you are giving 50 Newton, the floor also giving 50 Newton to you. It is equal, right? Because if you are giving 50 Newton, the floor doesn't give 100 Newton. Then when you are trying to push a box, you will be pushing to this kind of direction. The man will push to the opposite direction. So it can't be happen, right? So when you are giving like 50 Newton kind of power to this one, the flow is also giving the same but opposite in direction. That is the term. Same strength එක දෙනවා but opposite in direction. ඒක resistive කියන්නේ ඒකයි. එයා යන දිශාවට දෙනවා නම් it's like helping to that motion නේ. It's not helping to that motion. එයා කරන්නේ යන්න නොදී resistance එකක් තියෙන. යන්න එපා කියලා. දැන් likewise ප්‍රතිරෝධය කියලා අපි කියන්නේ යන්න එපා. යන්න දෙන්නේ නැතුව නවත්තන එක තමයි කරන්නේ. So applied force should make a අඩුයි නම් when it is less than the friction, what happen is there's no movement. So you can see here 50 Newton ඔයා දෙනවා මේ අතට, then the flow is giving 50 Newton to this direction mean equal and opposite direction මොකද වෙන්නේ cancel out වෙනවා. So there is no net movement and there is no net force. net force එකක් නෑ මොකද direction එක මේ අතර යන එකයි මේ අතර යන එකයි ආවම ඒක cancel out වෙලා යනවා. ඒතර කොහෙටවත් move වෙනවද නැහැ. මං කියන එක තේරෙනවා ඇති කියලා හිතනවා. And then if the applied force is greater than the friction එකට වඩා apply කරන force එක වැඩි නම් what happen? Now in this case think you are giving 100 Newton. Think this flow only can give 80 Newton. That is its maximum level. There is a maximum level for this flow also. Flow එකටත් කැමති දේවල් කරන්න බෑ. එයාටත් තියෙනවා maximum level එකක ඒ resistive force එක දෙන්න පුළුවන්. ඒක පහු කරාට පස්සේ මොකද වෙන්නේ? ඔයා දෙනවා 100, you are giving 100 Newton. So you can now cancel out this 80 Newton opposite. Then objects start to move to this direction. That's what happening. That's why it is termed as unbalanced force. Now to the 80 Newton, 100 is not balance, which is called unbalanced. So there is unbalanced force, then object moves. This is the real theory behind the motion. There should be an unbalanced force. On very smooth surfaces, what happen? Example like ice, small force can cause motion because friction is minimal. Think a real situation. If you want to walk in a very rough floor and think like you are walking on ice or a slippery road. අපි කියන්නේ slippery නැත්නම් අපි තෙත් උන ice වගේ මොන හරි තියෙන පාරක road එක you want to work in both places, which is more easier. I know everyone is telling it is ice තියෙන නැත්නම් bed තුන slippery road එක තමයි it is easy to walk. But when you think about the very rough roads, it's very hard to walk. ගොඩක් බොරළු තියෙන and like very rough road එක ඇවිදින්න අමාරුයි. Because in those roads the friction is higher, but when it's come to the smooth surfaces like ice, then what happens is the friction is low. That means the resistive force against your motion. ඔයා ඇවිදිනවා කියන ඔයා ඉස්සරහට යන්න try කරන එකනේ. දැන් මේ motion එකට against දෙනවා මොකද්ද? flow එකෙන් resistive force එක which is called the friction. හරිද? එතකොට smooth surface එක ඇවිදින්න easy because the friction or the resistive force is lower. I hope you guys understood. So then we can discuss about the effects of the force direction. Example, think a cart is pulled by a bull. ඔන්න දැන් ඉන්නවා බුල් කෙනෙක්. අපි හිතමු සාමාන්‍යයෙන් කරත් අදින හරකෙක් ගැන නෙවෙයි කියන්නේ. දැන් ඔන්න හරක අදිනවා කරත් එකක්. I don't know how to draw. Anyway, think this bull is pulling this cart to this direction. What happened? Think from the behind a man is pushing to that direction. What happened? What happened to the speed? You know definitely from your experiences, speed should be increase. යන පැත්තටම if we push කරොත් අපි ගිහලා කවුරු හරි කෙනෙක් push කරොත් යන පැත්තටම what happened? The speed is increasing, right? So think from the opposite side. This cart is want to go to this side, but this man is pulling to this direction. That means the opposite direction. Think he attached a rope and pulling to this direction. What happened? Now the motion is this direction. He is pulling to the opposite direction. What happened? The speed should be decreased. That means you can understand kind of a point. Force has a magnitude and a direction too. That's why this kind of thing is happening. If you are applying same 50 Newton to this direction, speed is decreasing like this. But if you apply the same 50 Newton to this direction, that like you are supportive to the motion. අර බුල් යන ඩිරෙක්ෂන් එකට ඔයා සපෝට් කරනවා ඒ කාට් එක ඇදලා යන්න. එහෙම කරොත් if ස්පීඩ් එක වැඩි වෙනවා. හැබැයි ඔයා යන පැත්තට විරුද්ධ පැත්තට එක ඇදලා opposite direction එකේ force එක දුන්නාම මොකද වෙන්නේ? ඔන්න යන ස්පීඩ් එක අඩු වෙනවා. That is the basically theory behind this. And in my previous video under the unit 2, I discussed about the vectors and the scalars. Physical quantities අපි බෙදනවා vector scalars විදියට. To be a vector, a physical quantity should have magnitude and the direction both. But if it is scalar quantity, it doesn't have a direction. Direction එකක් නැහැ. Only the magnitude. Example like time. Time එකට මට direction එකක් කියන්න පුළුවන්ද? බෑ. හැබැයි මට 5 seconds, 10 minutes, 1 hour like I can say a quantity, right? I can't say a direction. Force එක ගත්තාම මම force එක කියද්දි කිව්වා value එකක් කිව්වා නේද? මම 50 newton කියලා මම එකට magnitude එකක් දුන්නා. මම ඒක direction එක කිව්වා නේද? මේ this man is pulling to this direction. Likewise, I always use the word direction. I can show to this direction this force is acting. So remember, it has the magnitude and the direction both. So it is a vector quantity. It's not a scalar quantity, right? Then the line of action. Usually the line of action is starting from the point of application. Think there is a rope and this man is pulling, so that point of application is here where it is starting, and the direction of force is here, no? So if you join these 2 points to the direction, if you are showing from the point of the application and you are showing the direction, this line is what? The line of action. අපි යන්නේ action එක සිද්ධ වෙන line එක. ඒ line එක කියන්නේ දැන් ඔයා යන force එකේ direction එක පෙන්නපුවාම මේ අඳින ඉර තියෙනවනේ. ඒක ඊතලයේ ගැන හිතන්න එපා. ඒ යන ඉර තියෙනවනේ. ඉරෙන් පෙන්නන්නේ the straight line is showing the direction of the force. ඒ force එකේ direction එක තමයි පෙන්නන්නේ. ඒතර ඒකෙන් කියන්නේ ඒ line of action. ඒක act වෙනවා. ඒ කියන්නේ මේ තියෙන action එක act වෙන line එක. මේ line එක දිගේ තමයි මේ force එක act වෙන්නේ. මේ බුල් අදින්න මේ direction එක දිගේ මේ line of action එකේ තමයි යන්නේ. අන්න ඒ වගේ. Now we already finished in discussing what is force and how it can bring out different kind of effects. So දැන් අපි force එක කියන word එක ඉගෙන ගත්තා. මෙතනින් එහාට අපි යන්නේ force එක කියන වචනේ use කරලා ඉවර වෙලා අපි එක එක laws කීපයක් ඉගෙන ගන්නවා. මේ බලද්දී force කියන word එක important දෙයක්. ඒක නිසා තමයි force කියන එක ඉගෙන ගත්තේ. So when it's come to the Newton's 3 laws of motion, from its name you can see something related with Newton person, right? Newton person වහලා ඇති. Isaac Newton. So Isaac Newton වහලා ඇති. He's a scientist, right? There is a famous story, you know, there is an apple, it fall on his head. What happened? He was thinking about the gravitational force, so on. Like, so he's that famous one. Even people like us thinking about how to eat this apple, he thought about different kind of things, right? Gravitational force, like that. So we are here discussing about 3 laws. There are 3 Newton laws. Newton ගෙනාවා මේ motion එක ගැන laws 3ක්. 3 laws, right? 3 laws ගෙනාවා. So one by one we have to clarify, right? We have to know what is that law, the definition, right? You have to define what is that law is, and also you have an idea about in general life in which kind of situations these kind of laws are used to describe. මේ law එක කොහොමද අපේ day to day life එකේ තියෙන activities වලදී අපි ඒක දකින්නේ, කොයි තැන්වලදීද අපි මේ law එක දකින්නේ, ඒක ගැන idea එකක් තියෙන්න ඕන. And when it's come to the Newton's second law, there is an equation, we have to do calculation with that. And when it's come to the third law, same as the first one, you have to know the definitions and you have to know some examples. That's all for the laws. So first we are moving to the Newton's first law. There is another way of telling it, law of inertia. We'll see what this means. In your textbook, the definition is given like this: until an unbalanced force is applied, bodies at rest remain stationary and bodies in motion continue to move at uniform velocity. From the first instance, you guys will feel like confusing, right? What this means. There are like unbalanced force, remain stationary, continue to move, like quite different words. But we have to break down this statement part by part and have to understand what it really means, right? Don't like to be like by heart these things, but if they won't give, like, you have to write it, right? So you have to be able to understand first and remember how to write it, or you can use your own words as possible. Anyway, let's break down this first part. Until an unbalanced force is applied. When we are discussing previously, I said about what is an unbalanced force. Think there is an object, you are giving 100 Newton force to this one. I said the flow is also trying to give a resistive force against your motion. I think you guys can remember. You are giving 100 Newton, but this flow is trying to give a resistive force. Think it's also giving 100 Newton. Does this body is move? Does this body move? No, right? No movement. But think its limitation is like 150. So you are giving a 200 Newton. Flow එකට දෙන්න පුළුවන් maximum resistive force එක think කරන්න 150 Newton. The maximum resistive force the flow can be given is 150 Newton. But now you are applying 200 Newton. So what happened? No, it can't. It can't give the same force. So now your 200 Newton force is greater than the frictional force. So there is a motion. Now think from this and understand this statement. Here, this is a balance force, right? 100 giving and friction is also 100 balance, right? But in here, unbalance. You are giving 200, but this flow can only give 150 Newton. So what happened? This box is start to move to this direction. So this condition 200 150 means there is an unbalance. They are not equal. Equal forces දුන්නොත් විතරයි ඒක balance වෙන්නේ. Opposite direction දෙන්නත් ඕන equal forces උනම තමයි balance වෙන්නේ. Equal නොවි ඒ කියන්නේ opposite direction දුන්නාම මොකද වෙන්නේ? Unbalance. So until an unbalanced force is applied. Unbalanced force එකක් දෙනකන් until that unbalanced force is giving to that box, what happened? The body at rest. You know at the beginning these boxes are at rest, right? At the beginning the box at the rest. So unbalanced force එකක් දෙනකන් rest එකේ තිබ්බ body එක. The body at the rest remains stationary. Stationary කියන්නේ that object is remain at the same place. Stationary means rest or the same place. It's not moving to any kind of place. So this is this part. මේ part එකට තියෙන example එක තමයි මේක. Right? ඒක පේනවනේ stationary, no movement, stationary. Why? There is no unbalanced force. මේකේ කියන unbalanced force එකක් දුන්නොත් විතරයි මේ කියන object එකක් move වෙන්න ඕන. ඉතින් මෙයා ඉන්නේ stationary. ඇයි ඒ? rest එකේ ඉන්නවා stationary. unbalanced force එකක් නෙමෙයි තියෙන්නේ එතන. And the body is in motion. rest එකේ ඉන්න කෙනෙක් ඉන්නවා මේ විදියට. අපි හිතමුකෝ think there is an vehicle moving with 200 meters per second. එකම velocity එකකින් යනවා. think 200 meters per second වලින් ඔන්න object එකක් move වෙනවා. They are called bodies in motion, right? Move within object එකක්. Continue to move at uniform velocity. What this mean? Uniform velocity එකෙන්ම යනවලු. That means 20 meters per second යනවා නම් if you guys look at that vehicle 1 minute වලදීත් 20 meters per second මයි. After 30 minutes also the speed is 20 meters per second. It's not changing with the time. Harida? That's why to increase the speed we are giving kind of acceleration, right? I think in the previous lesson I did under unit 2 we discussed about what is acceleration and deceleration and so on. And there also I discussed about uniform velocity too. Uniform velocity means the velocity is not changing with the time. Time එකත් එක්ක velocity එක වෙනස් වෙන්නේ නැහැ. කියන්නේ දැන් 20 meters per second නම් 5 minutes වලදී බැලුවත් 10 minutes 30 minutes කොච්චර වෙලාවෙ කොයි වෙලාවෙ අපි record කරලා බැලුවත් the speed is does not change. Speed එක වෙනස් වෙන්නේ නැහැ. So as in here අපි unbalanced force එකක් කියන්නේ හිතන්න අපි vehicle එකට unbalanced force එකක් කියන්නේ ඒක යන්නේ සාමාන්‍යයෙන් හිතමු 450 නිව්ටන් කියලා. මේ force එක වෙනස් වෙන්නේ නැහැ පොඩ්ඩක්වත්. එහෙම force එක වෙනස් නොවි එකදම force එකෙන් ගියොත් එතකොට මේ motion එකේ motion එක වෙලේ තියෙන speed එක තියෙන්නේ ඒක වෙනස් වෙන්නේ නැහැ කියලා තමයි මේ කියන්නේ. අපි හිතමු මම පිටිපස්සෙන් ඇවිල්ලා you are giving an extra force of like 100 Newton to this 450 Newton. What happened? Now the speed is increasing as what I discuss in here. If you given force to the same direction, what happens? Speed increasing. But if you are giving force to the opposite direction, think something is giving force to this direction. What happened? එතකොට යන පැත්තට විරුද්ධ පැත්තට ෆෝස් එකක් දුන්නකම මොකද වෙන්නේ? ස්පීඩ් එක වාහනේ අඩු වෙනවා. ඒක මම ඩිස්කස් කරානේ. thinking same way. ස්පීඩ් එක වෙනස් වෙන්නේ නැහැ. ඔයා ෆෝස් එකක් නොදී හිටියොත් එතකොට. කිසිම ෆෝස් එකක් නොදී හිටියොත් අන්බැලන්ස් නෑනේ. එයා යන්නේ තමන් මුලින් ඉඳන් තිබ්බ බැලන්ස් ෆෝස් එකේමයි. එතකොට කිසිම ෆෝස් එකක් නොදෙන තාක්කල් it can move in the speed as it was at the beginning. මුලින් තිබ්බ ස්පීඩ් එකෙම කන්ටිනියු වෙලා යුනිෆෝම් වෙලොසිටි එකෙන් යන්න පුළුවන්. ඔය අන්බැලන්ස් ෆෝස් එකක් දුන්නොත් මොකද වෙන්නේ? ඒක මූව් වෙනවා. මේ ඒක මූව් වෙන්නේ ඇක්සලරේෂන් එකක් එක්ක හරි ඩිසලරේෂන් එකක් එක්ක හරි මූව් වෙන්න අරගෙන ඉවර වෙලා there is an unbalanced force. So I think this definition is now clarified. So we have to discuss about what are the examples in real life where we have to think about this first law and how it's applying in those cases. So first thing, it is the carom board, right? I think it is very familiar to the people. Think you are applying a force to this disc, right? There is a disc. What is the state before you are applying a force? It is at rest, right? What you are doing now? You are giving a force like this. Now what happened? At the initially, it's try to giving a resistive force to your force. ඔයා දෙන්න force එක මේ අතර නම් you are giving to this direction, but this disc is want to resist. ඒකට ඒක නවත්තන් ඉන්න try කරනවා. But what happened? ඔයාගේ force එක your applied force is more. Think like this is 200 Newton and this is 50 Newton resistance. Then what happened? Your force is larger. What happened then? Disc is more to this direction. Okay. So that is also describing the first law. Until an unbalanced force is applied. What happened? You are applying an unbalanced force. Then what happened? The body at rest will not remain at the stationary because now there is an unbalanced force, right? Unbalanced force එකක් දුන්න නිසා rest එකේ තිබ්බ body එක මොකද වෙන්නේ? stationary ඉන්නේ. ඒක තේරෙනවා ඇති. unbalanced force එකක් දුන්නාම rest එකේ ඉන්න කෙනා rest ඉන්නේ නැහැ. ආ move වෙන්න ගන්නවා. හරිද? Okay. Then passenger in a bus. Think you are as a passenger. I think most of people are always passengers in bus, right? So this is a very common incident. When bus stops suddenly, what happened? Think you are inside the bus, right? Then bus is moving to this direction. What happened? Now the bus is stopped suddenly. Bus is stopped. Bus stopped. But what about your body? It still try to move to the direction of moving. Why is that? Stop කරපු ගමන් ඔයා ගිහින් ඉස්සරහට මෙහෙම lean වෙනව නේද? ඒ කියන්නේ you are trying to lean into that direction. When there is a bus, when the bus is stopped, what happened? Your body is starting to lean toward that direction. Even bus is stopped, your body is moving still to that direction. Think theoretically, why is that? If you want time, you can pause the video and think. And also the next case is when bus starts suddenly, you're falling backward. Why is that? Now think which part are contact with the bus. That's why we are telling you have to increase more contact with the bus. Why is that? If you are having more contact with the bus, right? If you think you are standing in the bus, you have to have good contact with the seats or the upper part of the bus. You know there are hangers. why we are hang them, and why we are holding the seats and everything, like we want to like be part of the bus, right? Unless bus is moving, you the force is not transmitting to your body. If you don't have a good contact with the bus, then bus is stopped, but you are still moving because the force is doesn't move to your body. That is basically happening. That's why ඒක නිසා තමයි අපිට කියන්නේ බස් එකේ යද්දි මොකද කරන්න ඕන? අපි ඒකේ තියෙන මේ සීට් එක හරි උඩින් එල්ලෙන කෑල්ල හරි අපි අල්ලන් යන්න ඕන. We have to make a good contact with the bus unless ඒ බස් එක නතර වෙලා ඒ ෆෝස් එක හම්බෙලා යාට but ඔයාගේ බොඩි එකට තාම මේ ෆෝස් එක ට්‍රාන්ස්මිට් වෙලා නැහැ. ඔයා තාම ඉස්සරහට මූව් වෙනවා. ඒක හිතන්න පුළුවන් from this law, right? Until that unbalanced force is applied. ඒ unbalanced force එක දැන් අර බස් එක නතර කරාගෙන unbalanced force එක apply වෙන්න කලින් apply වෙනකන් මොකද වෙන්නේ? The body in motion. You know your body is under motion when you are moving in the bus. ඔයා move වෙනවා කියන්නේ බස් එක move වෙනවා කියන්නේ දෙකම එකයි. කියන්නේ බස් එක move වෙනවා කියන්නේ you also moving with the bus. So until that stop unbalanced force is applied to you, your body still continue to move with that previous uniform velocity of the bus. Think the bus is moving at 20 meters per second at the beginning. So your body is trying to move at 20 meters per second, but bus is stopped. Now bus velocity is 0. Your body is still try to move at 20 meters per second. That's why your body is fall forward. Okay, then think the opposite side. Now bus starts suddenly. Your body is at zero velocity, but this bus is start to moving at 20 meters per second. Now think in the opposite way. If this unbalanced force is not transmitted to your body, what happen? Your body still try to remain stationary, right? This part of the definition is working when the bus is starts suddenly. Your body start to remain at rest and in stationary way, but bus is start motion. ඔයාගේ බොඩි එකට තාම ෆෝස් එක ට්‍රාන්ස්මිට් වෙලා නැහැ. ඔයා තාම ඉන්න බලනවා stationary විදියට, but bus is start to move. That is the thing happening. That's why always telling we have to keep a good contact with the vehicle. That's why we are wearing seat belts too. That's why we are wearing seat belts to what happen? If there is no seat belt like this thing, your vehicle is stopped due to this kind of accident. Now the vehicle is 0 meters per second, but think before this car becoming 0 due to this accident, think your car is riding with 60 meters per second. Then your body is trying to move with the 60 meters per second forward, and you may go out of this glass and come out of this vehicle. So to prevent that, you have to maintain a good contact with the vehicle. Then suddenly if you accident, or if you if you give your brakes and whatever the thing you are doing, if you start motion, or if you are applying brakes, or if you are facing an accident, whatever the thing happening, any kind of unbalanced force, your body also moving with the vehicle. That's what basically happening. ඔයා මේකෙන් ගැලවිලා එළියට යන්නේ මොකක්වත් වෙන්නේ නැහැ. ඔයත් මේ අන්බැලන්ස් ෆෝස් එකත් එක්කම කාර් එකේ නතර වෙනවා නම් නතර වෙනවා, යන්න පටන් ගන්නවා නම් යන්න පටන් ගන්නවා. ඇක්සිඩන්ට් එකක් වුණොත් ඒ විදිහටම නතර වෙලා ඉන්නවා. ඔයා සීට් බෙල්ට් දාගෙන ඒ වෙහිකල් එකේ බොඩි එකත් එක්ක කන්ටැක්ට් වෙලා තිබ්බොත් හොඳට. because the force transmission is more easier. ඔයා එකත් එක්ක separate හිටියොත් මොකද වෙන්නේ? ඔයාට දෙන motion එක එන්නේ පරක්කු වෙලා. ඒ unbalanced force එක එන්නේ පරක්කු වෙලා. ඔයා අර මේ first law එකේ කියපු විදිහටම if you are at rest, you are remain as stationary, but if you are in under motion, you are continue to move at that speed. That's what happening. I think this is the one of the most complicated part to define as from the definition to understand. So I think with the examples too, it will be more easy to understand. So we can move to the Newton's second law. So this is very famous law because of this equation. When we are talking about the Newton, this is a very famous equation, and you can't forget this until you are writing the exam, right? So let's see what this law means, right? The acceleration of a body. Before moving to this, I highly recommend you, if you don't know these terms like acceleration, deceleration, uniform velocity, likewise, please watch my previous video or learn from anywhere else or something. You have to complete before you are watching the unit 4, right? Because if you don't know what is the term, what is these terms are, then you will be in a trouble. Anyway, the acceleration is increasing velocity. Velocity is also kind of a speed, right? Velocity කියන එකට අර මම කිව්වා වගේ vector quantity එකක්. ඇයි ඒ vector එකක් වෙන නම් direction එකක් තියෙනවා. දැන් මම කිව්වා 20 meters per second කියලා. ඒක මම කිව්වොත් මේ direction එකට කියලා මේක velocity එකක්. ඒකට direction එකක් තියෙනවා. හැබැයි අපි speed එක කියන එකට direction එකක් නැහැ කියලා කියන්නේ. නිකන් 20 meters per second නම් ඒක speed එකක්. දැන් මේ acceleration කියලා කියන්නේ, what is acceleration is increasing of the velocity, not the speed, right? මේ magnitude එකයි direction එකයි දෙකම තියෙන velocity එක තියෙනවානේ. Velocity increment is the acceleration. Okay? The acceleration of a body is directly proportional, and this is the mass part, right? What is directly proportional? Think if you increase something, as example, what happened? Let me take this one. I will finish this part up to here, right? The acceleration of a body is directly proportional to the unbalanced force. I talk about the unbalanced force, right, many times. So this is force now, which is F. This is acceleration, which is letter simple A. Think F and A. If I want to tell a relationship, they are telling they are directly proportional. Directly proportional is writing like this, right? In maths, what happen if you increase the force, acceleration is also increasing. Also like that, if you decrease the force, what happen? Acceleration also decreasing. That's what this symbol mean. Increase කරද්දි increase වෙනවා, decrease කරද්දි decrease වෙනවා. ඒක තමයි meaning එක. Directly proportional නම්. හරිද? So that's what it's written like this. Unbalanced force එකත් එක්ක acceleration එකත් එක්ක තියෙන relationship එක ගත්තාම, if you increase, force also increase, and also if you decrease, force also decreasing. And the next part of the statement, inversely proportional to its mass. That means if you take the acceleration, it is inversely proportional, inverse of the mass. Mass is m, right? Letter m. Acceleration, if you increase the acceleration, what happened to the mass? Mass is decreasing. So how we are representing is this way, 1 over m, to show it is inverse, not the directly way. If you increase the acceleration, mass will if you increase the mass, what happened to the acceleration? Acceleration is decreasing. And if you decrease the mass, what happened to the acceleration? Acceleration is increasing. The opposite thing is always happening. Okay? Let's see, you guys understood. Now I'm asking like questions, whether you guys understood what this directly proportional and indirectly proportional is. Okay? So if I say force is 100 Newton, okay, then and the force is 50 Newton, what happened to the acceleration in first case and the second case? This is first and this is second case. What happened? whether the acceleration will increase or decrease. As we know, acceleration is directly proportional to force. Now what happened? 100 Newton become 50. That means decrease, right? Force is decreasing. So what happened to the acceleration? Acceleration also decreasing. In the second example, think 450 Newton at the first instant. ඒක තමයි force එක දීලා තියෙන. Then you are applying in the second case you are applying to the same object, but now in this time 600 Newton. What happened? You are increasing the force. So what happened to the acceleration? It is also increasing because I said it is directly proportional. Okay. Then think about the masses, right? Now I have a 5 kg object. Now I change this object to 100 kg. What happened? Mass is increased, right? Mass increase. What happened to the acceleration? What will happen? If we increase the mass, as I said, if you increase the mass, what happened to the acceleration? It should decrease because the opposite is happening. Inversely proportional. So what happened? Acceleration should be decrease. That means the speed, it's not the speed, velocity is decreasing. As similar way, if you take 200 kg object and you change that object to the 5 kg, what happened? Mass decrease. Then what happened to the acceleration? Acceleration should be increased because the opposite thing is occurring in inversely proportional case. So by combining both of them, like here, right? Now above the denominator, at the denominator, force is there because it is directly proportional. You know, as it is inversely proportional to the mass should come below this line. Sorry, I did a mistake. This is the numerator, right? Numerator, and this is the denominator. So if you combine like this, now it is like this now, f over n. But if you want to subject f, I want the equation with the f, right? So you can take this m to this direction. So f equal ma. They are not asking to build this equation, right? You only know that f equal ma. This is a very famous equation. You can't forget this. Okay, you have to know this is the unbalanced force, and this is the mass, and this is the acceleration. Then unit of the force. I already mentioned several times the word Newton. I am applying 5 Newton, 10 Newton, likewise Newton word, right? As you know, the 5 kg, the kilogram is writing like this. For the force also, if I say like 10 Newton, the Newton is the way of expressing the unit of the force, right? Think F equal ma, no? So you are taking 1 kg, right? 1 kg object, and acceleration is 1 meters per square second. Meters per square second. I think if you don't know how to read this unit, try my previous video. Then what happen is we can write like this. Now the force is coming now, so you can directly write Newton, 1 Newton. That's what I want to say in here, but something wrong with the typing, so just forget this. The acceleration should be 1 meters per square second. The mass is, if 1 kg, so it's giving force is 1 Newton, right? Okay. So to demonstrate this, there is an experiment. What is this experiment? You are pulling the trolley with one rubber band. Okay, that means you are pulling means you are giving a force. No, pulling means pull is a force, right? At the beginning we learn pull, push, lift, compress. Likewise we are giving forces. Neither. So you know this card, right? There is a trolley like this, and there is a stick like this, and you are putting a rubber band around it, and you are pulling it, right? So if you get a one rubber band, it's accelerate. And you can see if you put two rubber bands and apply force, what happen? Acceleration doubles. Why is that? Now from one rubber band, think the force is F. Now you are using two rubber band, mean 2F. What happened to the acceleration? As you know, acceleration is directly proportional to the force. If you double the force, the acceleration should be double. And it is telling, if you increase the mass of the trolley, you are putting some stones. What happened to the mass? You are increasing the mass, right? You are increasing the mass of the trolley. What happened then? If you increase the mass, what happened to the acceleration? It should be decrease because of this law, right? Newton said this relationship. So we can demonstrate this with trolley, right? So as we know this equation, we have to do some calculations. So when it's come to the calculations, you guys can pause the video and answer by yourself and check my answer. So it's time to do the calculation. If you want, you can pause the video. So anyway, I'm going to do the sum. Question is telling, what is the force required to give an acceleration of 2 meters per second to a 5 kg mass? So I focus on what they are telling to find. What they are telling is to find the force, right? They are asking us to find the force. Okay. Then they are giving the acceleration. Acceleration is the letter A in that equation. And they are giving the mass. What is the mass? In 5 kg. You know from that equation, F or the force equal mass into acceleration. So 5 kg. Remember to write the units, right? They are giving marks to the units. Don't miss it. So 5 into 2, 10 Newton. Simple, right? Then we can move to the next question. Then you can pause the video and answer by yourself. So they are giving a force of 12 Newton is applied on a body. Now force or the F is given at 12 Newton. When you are doing the sum, as I marked what they are given like this, I think it will be very easy to find answers for the very hard questions. You don't miss any information, right? This one, and this is the important part. Mass is 6 kg. Moving at uniform velocity. Okay, uniform velocity in the direction of its motion. Okay. Find the acceleration of the body. So F equal ma F over m equal a. I think you guys know how to take this to how to subject the equation, right? Here we want the a, right? So keep a on that side, as this m is multiplied with the I think maybe easy for them. Okay, now m is multiplied with a, right? To remove the m from this side, because we want to find the a, no, a asking acceleration. So as m is multiplied with a, I can divide it from both sides, because as there is equal mark, you can't do anything to one side, so you have to do it to the both sides. So cancel from this side. Now they equal F over m. Now F equal 12 Newton. Mass is 6 kg. So 12 over 6 mean 2. As this is acceleration, what is the unit? Meters per square second. Okay. Then we are moving to the next question. If an acceleration, you can pause the video and find yourself the answers. The acceleration is what? Acceleration equal 2 meters per square second. It won't be in the same level, right? The minus 2 should be at the upper level. When the force is F equal 8 Newton, find the mass of the object. Asking about mass, right? The same equation. What is that? F equal ma. Now I want to subject m. m කියන එක equation එකේ subject කරගන්න ඕන. එහෙනම් as m is multiplied with acceleration, what happen? You can divide a from both sides, because as there is equal mark, you have to do the same thing to both sides. Now it is removing m equal F over a. F equal 8 Newton, right? 8 Newton, a equal 2 meters per square seconds. Now the answer is what? 4, right? As it is mass kg, kilogram. Okay. Let's move to here, right? These are from your textbook. Those are very standard questions that you guys have to practice. So now it is asking to complete this table with the force, mass and acceleration. What is the equation we have to use? Force, mass, acceleration is there in the F equal ma. So now at the first they asking about the force. Here 1 2 3 4, right? And 1 ma. What happened? Force, okay, the mass 3 kg, acceleration 2. What is the answer? 6, right? 6 Newton. 6 Newton. Then the force is 40. They are asking about the acceleration, right? So we can't keep like this. We have to subject acceleration. So acceleration equal force over m. Because we already know how to cut down and make that equation, how to subject, so I don't repeat the same. Then F force is 40 Newton, mass is 10 kg, which is 4 Newton. And the third one asking about the mass. So F equal ma. The mass is what? F over a. F is, or the force is 30 Newton, and the acceleration is 1.5 meters per square second. So how much is here? 300 over 15 is 20. And at the 4 in here, I think you guys know how to do this, because we can't divide the number by a decimal, so we are multiplying. To remove this decimal, we can easily multiply by 10 up and down both to remove this decimal. So it's become 300 over 15. Then the answer is 20. Fourth one is finding the acceleration. F equal ma. Acceleration equal F over m. Now the force is 2 Newton. 2 Newton. and the mass is 500 kg. This is the answer is like this. I don't have space here, so I write below. That's this question is finished. Let's move to the other two parts of that question. So if a force of 6 Newton is applied on a body, now 2A, force is what? 6 Newton, mass is 4 kg, moving at uniform velocity in the direction of its motion, finding the resulting acceleration. Same equation, right? Asking about the acceleration. F equal ma, a equal what? F over m. Then F is 6 Newton, mass 4 kg, 3 over 2, 1.5 meters per square second. Then in the B, if the above force is applied in the direction opposite to the direction of the motion of the body, find its deceleration. In here, think this 4 kg object is there, right? The force is 6 Newton applied this direction. Now it is telling the same force is applied in opposite direction. What happened? This box is moving to this direction now, so it facilitate and it's accelerate in this case. අපි යන ඩිරෙක්ෂන් එකටම ෆෝස් එකක් දුන්නාම ඒක මොකද වෙන්නේ? ස්පීඩ් එක වැඩි කරගන්නවා ෆැසිලිටේට් කරලා. බට් දැන් කියන්නේ opposite direction දෙනවලු ඒ ෆෝස් එක. Object move to this direction, but you are applying that 6 Newton to the opposite direction. Same 4 kg. What happened? Now it's not the acceleration. It should be deceleration, right? So what happened? F equal ma, a equal F over m. Force is to which direction? Opposite direction. So it is minus 6 Newton, 4 kg. The same answer coming, but opposite direction of that. So acceleration negative means what? It is deceleration. So no need to calculate this, but you can directly tell it is decelerating with 1.5 meters per square second. That's what happening. Acceleration negative is deceleration. It's also discussed in the previous physics unit, which is the second unit of grade 10, right? These two also completed. Okay. From there onwards the momentum. So I'm moving to the lesson again. So the next Newton's law is the Newton's third law, right? This is a very famous one. Let's see what is. For every action there is an equal and opposite reaction. They are talking about the two words, the action and the reaction. You are doing something and the reaction is coming. In Sinhala, this law is for සෑම ක්‍රියාවකටම ඒ හා සමාන ප්‍රතික්‍රියාවක් තියෙනවා කියලා තමයි කියන්නේ. Okay, let's see what it means, right? Okay, what is action and what is reaction? And if you think about its magnitude, it should be equal. Like if you are giving 50 Newton to this direction, you are this is your action, you are doing that, no? So there is a reaction force. Reaction is coming to the means same 50 Newton but in opposite direction. Okay, the action, reaction. Let's see from the day-to-day real life examples. Okay, think air is leaving from a balloon. You are blowing a balloon, right? At the first you are blowing a balloon and you suddenly get your fingers from the opening. What happened? What really happened? The balloon is start to move upward, right? How it's moving upward is the air molecules inside this balloon is pushing downward. Okay, now the air molecules coming downwards. Then what happened? As the reaction force, oppositely the same way the reaction is occurring to the upward. That's why it's moving upward. Okay, the balloon is pushing air molecules downward, but the air molecules in the balloon push it upward. Okay, and in this kind of situation I think it's more familiar for you. Think there is a wooden plank, right? ලෑල්ලක් තියෙනවා කියලා හිතන්නකෝ. ඒකේ යට you are keeping these marbles. අපි කියන ජිල් බෝල කියලා. එහෙම තියලා දැන් එතකොට මේක move වෙන්න පුළුවන්. ඒක ලේසියෙන්. තේරුණාද? Then the two children sit on these two wooden planks. Then what happened? This one is pushing this direction. This person is pushing this direction. What happened? You are pushing your friend. This one is pushing his friend. What happened? This person start to move this direction. This person move to this direction. Why is that? Because this is this person's action, right? Let's focus only on this person. That person action is to this direction, to this direction. But there is a reaction force generating for his action, so it is opposite and equal, opposite direction and equal force, so it is start to move to the this direction. Same to this person, right? This is his action force and his reaction is to the opposite direction with same magnitude. If it is 50 Newton, you are pushing your friend to the direction, that same person moving to opposite direction with the 50 Newton. That's what happening. And here too, think there is a rope, right? This is a rope and a straw. Beam බටයක් හිතන්න. So you are hanging a balloon like this. You are attaching balloon to this straw. Then you know if this balloon is moving here or there. With this straw in, it can easily move, right? Let's think this air is moving to this direction. What happened? The balloon is start to move in this direction, like in the previous case. What happened? The air molecules start to move to this direction. What happened to the balloon? It start to move opposite direction. Same thing. And when it's come to the rowing a boat, boat එකක් පදිනකොට මොකද වෙන්නේ? Boat to a post, right? You push against the water. So if you want to move forward, you have to push the water toward which direction? You have to push the water to the opposite direction. Then only the boat is moving forward. If you also if you also push the water to this direction, you will be go to the opposite direction. That means you are going backward. Okay. In next case, swimming, right? If you want to move forward, what happen? You have to push water from your hands to the backward. Then only you are moving forward. So this is the action. So this is the reaction force. So you are pushing the water to backward. That is the action. Then the boat is moving toward front side. That means this is the reaction. Okay. That is what basically the Newton's third law. So there, I think all three laws now over. The special thing in here, the second law, is we have to do some calculations. Other than that, you have to know what are the examples in daily life. Likewise, Then we can move to the momentum. What is momentum? It's not a Newton law, right? Momentum is a separate thing, like what I explained in the force. Force is a separate term. Momentum is also a separate term. Okay. Momentum, from the definition, it's telling the measure how difficult it is to stop a moving object or a moving body. Think something is moving. Every object is not easy to stop. Think about small ball, like let's think in the ground, right? Towards your side there is a plastic ball is coming with a 20 meters per second. I'm always taking 20 meters per second, right? Okay, anyway, there is a plastic ball coming towards you. Okay, you are catching it means you are stopping it now. So this case, right, you want to stop a moving body. So we want to know how it difficult, right? That's what we are measuring. So there is an iron ball. Iron, steel, or very heavy things, heavy metals used to make that ball, right? It's also 20 meters per second, but it's coming towards you. What is more difficult to stop? Now think, what is more difficult to stop? I know you guys can stop both, but if it's pushed against your hand, what you feel more hard? I mean, how it's difficult to stop the steel ball and the plastic ball. It's very obvious that the steel ball is very hard to stop than the plastic ball, but it's same velocity, right? Likewise, we can observe this kind of things in daily life. Even the velocity is similar if the mass is changing. Than the plastic ones, the iron one, in come the mass, it's very heavier, right? So it is so hard to stop. But think like these two. Even though the mass is lower in a bullet shooting from a gun, right? And heavy ball than bullet, heavy ball coming than that, but mass is larger. Mass is larger, but its velocities, what about the velocities? Even though this is from its size it is larger, but it's come to the velocity, the bullet has a very high velocity. So can we stop a bullet from the gun? I know in India, yeah, there are in film industry of India, yeah, you can stop it, right? But in real life you can't stop a gunshot, right? So the bullet has a very high velocity. So if the velocity is also high, it is difficult to stop. So from these two examples, I think you guys got an idea. If the mass is higher, very much higher, but the velocity same, you guys saw that it's hard to stop. And also if the velocity is too much high, also it is difficult to stop. By combining these kind of tests and by doing several experiments, they find out the momentum or how it's difficult to stop a body, which is momentum is represented by the letter P, right? It's not letter M, right? Like it's odd. Usually we are taking the first letter of the word, no? So but in here, remember, momentum is representing with letter P, not the M. Simple M is mass. Momentum is equal to mass into velocity. That's what they found. The scientists found the momentum is equal to mass into velocity. So as I discussed in here also, we saw something related with the mass and the velocity. So if you know the equation, that's what they need. You can do calculations. And there for force, we learned that the unit is for force, what is the Newton, but for the momentum we are combining the unit of these two terms. Mass is what? Kilogram, multiplied with velocity. Velocity is what? Meters per second. So the unit is this one. But in force we are not writing like mass is kilogram, acceleration is meters per square second, so this is the unit. No, not that way. We are doing that to the momentum only, because to give the credit to the Isaac Newton, we are using this Newton. Okay, not this one. Okay, so if you guys understand this, you know the unit here also. This is kilogram meters per second, and also it is also a vector quantity. We discussed about the force also. I said it is a vector quantity which has a magnitude. That means you can say a value like 200, 100, 1000. Likewise I can say a value which is a magnitude plus what? The direction. You can tell a direction, that is to this direction or this direction. Likewise you can tell a direction. So those are vector quantities. So the factors affecting the momentum are what? The mass and the velocity. Those are the two factors affecting to the momentum. Then we can do some calculation with this equation. Let's move to this. The momentum of a body of a mass is given. Now they are asking about momentum. What is the symbol? P. Asking P. The mass is for how much? 200 kg. Then the velocity is given. You can't keep like this. You have to put that to upper. That means like this, -1 at the above top. So momentum equal what? Mass into velocity. Mass is 2000 kg, 20 meters per second. Now 4 zeros coming. The unit is combining the units of both here and here. This is the momentum. Now there are some other questions from your textbook. Let's do those questions. So the first one, they are asking mass is given what? 800 kg. Find its momentum. Momentum asking when it's moving at a velocity 5 meters per second. So what is the equation? Momentum equal mass into velocity. Mass equal what? 800 kg. Velocity is 5 meters per second. So 42 zeros kg ms. Okay. Then the first question is over. Then the second one, the mass is 600 grams. You have to focus on those ones too. But they given mass is 600 grams. But we know in equations we are using only standard units. As gram is not a standard unit, you have to convert into the kilogram when you are doing the sum. And find its momentum when it is moving at velocity of 5 meters per second. Velocity is 5 meters per second, right? So I think the space. So now asking about the momentum. So momentum equal mass into velocity. Now mass is 600 grams. To convert it to the kilogram, we have to divide it by 1000 kg. Velocity is 5 meters per second. So these two cancel. 1, 2, 3. 3 kg meters per second. Then third one, Object has a mass of 200 gram. It's moving with velocity 4. What is the momentum? 204, right? Okay. Third one. Mass is 200 gram. Velocity is 4. Asking about the momentum. Momentum equal mass into velocity. Mass in here 200 grams, you have to convert it into the kilograms by dividing it 1000. So it's like this, 4 meters per second. So here here it is 0.8 and let's move to the other page. We did these things, right? So I'm going from the fourth one. The momentum of moving object is 6. P is given as 6 kg ms minus 1. Find its velocity. Asking about velocity. It has a mass of 500 grams. P equal m into v. We have to subject v here. So as the m is multiplied with v, I have to divide m by both sides. Then this cancel. V equal p over m. So 6 kg ms minus 1. We know that it's easier than dividing like here. I will easily write in here 500 grams is divided by 1000 to do the kg, then 0.5 kg. So I can add that 0.5 kg here. What happened? It's become 12, right? Yeah, meters per second, right? This one is okay now. And the fifth one, the object mass is 3 kg projected upward. At the beginning of the motion, its velocity is 100. What was its momentum at the moment when it was projected? Asking when it was projected, right? So the fifth one, A, when it is projecting upward, what is the mass? 3 kg, right? 3 kg mass. Velocity is 10. Asking about the momentum. 10. Asking P. So P equal m into V. 3 kg 10 30 kg ms minus 1. Okay, so what would be the momentum when it reaches the highest point? It is a tricky one, right? Think you are pushing a ball at 10 meters per second. What happened with the time? It will go up and here stop and it start falling down. That is the thing usually happening, right? So when it reaches the highest point, what is the velocity? Ball should be stopped, right? That means what happened? At the highest point, if you throw a ball, at the highest point it is stopped. That means the velocity is 0. That means if you do this sum like m into v, what about the v? V becomes 0. If you multiply any number by 0, what is the answer? It is 0. That means momentum is 0 in this question, the second part. Okay, it's a nice one. Let's move to the last part of this lesson, the mass and the weight. So mass is the amount of matter in the object. That's what we are basically telling when someone is asked what is the mass. You are always telling in kilogram how much its matter is, the amount of the matter. Matter එක amount එකයි කියන්නේ. But when it's come to the weight is a force. That means how much of the force is attracting that object toward the earth. When we are discussing about the unit 2, right, we said about the gravitational acceleration to the gravity. I said in there also gravity is a force. Gravity, that's what the Newton famous, right? Newton was sat down on a tree afternoon, right? Sorry, I means evening time. So apple fall on his head. Then he thought about there is something force from the earth which attract the objects. That's what he thought. We are thinking about how to eat the apple, right? So anyway, this is which force? That is gravity. That is gravity. So that force, with how much of force the object is attracting toward the earth, is the weight. So we can combine this mass and this weight, and we can make equation. The weight, or the W is here, is the weight. Weight equal mass, G is what? Gravitational acceleration. In the unit 2 also we discussed what is gravitational acceleration. So gravity force is accelerating that object toward the earth, no? So that is that gravitational acceleration. Usually the true value is 9.8 meters per square second, but for easiness of calculations we are using it as 10 meters per square seconds. So think your mass is ඔයාගේ බර අපි හිතමු that's 50 kg person. So the gravity is this much we are taking. So weight එක හැවොත් කවුරු හරි weight equal mass into gravity, no? Mass is 50 kg, the gravity is 10 meters per square second, so 500 Newton. Again, this is, I said, weight is a force, right? So you can't change the unit of the force, which is Newton. And also it is telling acts through the center of gravity. We know the center of gravity is the point through which the gravity is acting. Think about a symmetrical object like a box. At the center, you can easily find this center, right? Inside the middle you can see at the center, this is the center of gravity, where the gravity acts, usually the center. Okay, so through the center of gravity the weight is acting. So due to this you can say, the mass is not changing when you are going from any kind of place. Even though you are living on earth, even though you are going to the moon or any kind of planet, the mass is not changing because the amount of matter not changing. But the gravitational acceleration or this acceleration is different from planet to planet. So usually in moon, think your earth gravity is G, but in moon it is G over 6. That means 1/6 of the gravity from the earth is the gravity in the moon. That's what I write as G over 6, which is what is the value? 10 over 6, because G is 10 meters per square second. So if your weight is 500 Newton in here in earth, what is in moon? In moon, 500 divided by 6, right? This is the way. If you know all these, you can easily do the sums in here also. We can do some questions. I got this is the last question. So in here it is telling the weight of an object is 5 Newton. Weight equal 5 Newton. At a certain instant, its momentum is, this is like combining different kind of equations maybe. We'll see, because the momentum is also telling. Momentum is what? 6 here. Due to a force applied in the direction opposite to the direction of the motion, the velocity of the object decreased to 6 during 4 seconds. Okay, velocity is decrease. 4 meters per second. Initial one is not given. Okay, what is the force exerted on the object? Asking about force. We don't know at the beginning what is the velocity, right? Beginning velocity we don't know, but they are telling it is decreased to 4 meters per second. As this is the last question, I got this kind of something that is logical and you have to think a lot more than the questions we already did. So if you want to try, you can pause the video and think. It's more better than looking at this. Okay, so they didn't give initial velocity, but they are telling it is decreased to 4 meters per second. Okay, before we are finding force and everything, it's better to find initial velocity, because we don't know from which velocity it is decreased, right? So as we know, the momentum equal what? Mass into velocity. Do we know the mass? But they gave the weight, right? Weight equal what? Mass into gravity. So if we want to find the mass, weight should be divided by gravity. Weight is 5 Newton. Gravity is 10 meters per square second. So the answer is 0.5 kg. Now you know the mass, 0.5 kg. Velocity, that means the initial velocity. The momentum given as 6, right? 6 kg ms minus 1. So the V initial is 6 over 0.5. What is the answer? 12, right? Because meters per second. Then what happened? You know the initial velocity. Now you know it. So after applying a force, this 12 meters per second decreased to 4 meters per second within how much time? 4 seconds. Okay. What is this deceleration? If we find that, you know, deceleration is negative acceleration too. So if you find this, as they are telling we have to find force, I think better to find the acceleration. Even though we know the decreasing of velocity is deceleration, we can find acceleration, right? Acceleration is what? Velocity, final velocity minus initial velocity over time. What is the final velocity? 4. Initial velocity 12. The time is 4 seconds. Now what is the answer? Upper part becoming minus 8, 4, it is minus 2. As it is acceleration minus, then you guys can see it is minus, right? Why it is minus? Because the velocity is here decreasing, right? So velocity decrement is deceleration, but as we find acceleration here, it is coming as negative sign. So now we know the acceleration. They are asking about the force. What is the force? Force equal m into a. What is the mass? We find mass as 0.5 kg. Acceleration minus 2. That is 1, right? 1 Newton to the opposite direction is applied. That's why it is representing with this minus sign. Opposite direction from the moving side. Object is moving to this direction. This opposing force is object toward this direction. That's what it's telling. I think everything I covered regarding this lesson. If you feel any doubts, or if you guys having any kind of questions regarding the lesson and these questions, feel free to comment uh, and practice many more questions, and see you all in next lesson, and have a nice day.